Hello, friends. Welcome to Coding Garden. And it's been a while, and we've done a lot of work since I last saw you. So in this video, I'm going to summarize the work we've done on Listed, which is an app that allows users to create, share, and watch lists of YouTube channels. Now, the last time I saw you, we had created the create page, but we only allowed title and description for the specific list. Now we've integrated the YouTube API, so you can actually add channels to a list during creation. So let me show you an example of what that's going to look like. Let's go ahead and create a list. Let's call this Svelte channels. All the Svelte channels. Now, I'll be honest, I actually don't know all of the Svelte channels, so I just knew of a few. But here's what happens. In this little search box, you can put in a term, and this actually calls the YouTube API. And gives back all of the channels that match that. So for instance, we could add Svelte Society. You click add. That's going to be in the list now. There's also a channel called Svelte Mastery. And then I know of Joy of Code, who's Mattia, and they post a lot of Svelte videos as well. We're going to go with these three channels. Essentially, what we need to do whenever we click create is we create a list in our database with this title and description, but we now need to also create these channels in our database and then associate them with that list. So some of the work we had to do was to update our database schema a little bit. So you can notice here that we're also showing like the channel name, the handle, number of subscribers. There's various information about the channels that we want to have in our database so that way we can use in multiple places. And so for that, we actually added a new table called YouTube Meta. So if you don't remember our database schema, basically we have a list. That's the top level item that will be created for this list with this name. And then a list has a set of list items. And this has the top level information, like just name and description. So this will be like channel name, channel description. And then it also has meta. Now, meta is generalized, but can have a type. And you can see right now, list item type is just YouTube channel. But the thought is eventually we could bring in other services. And so list item meta could be of a different type. So it could be Instagram or TikTok. For now, everything's just YouTube channel, which is why you kind of see this bit of indirection because it's list item meta. And then if it is a YouTube channel, it'll have YouTube meta. So these are YouTube specific things like subscriber count, banner URL, is verified. So all of these things are specific to YouTube. If we were to add, let's say, like a TikTok meta, then it would have other properties that are not specific to YouTube. So that's why we have like 3 levels of indirection. And when we add a channel to a list, we need to first create the list item meta. So that way we can associate it with a list item. And we create the YouTube meta. So we have all of this information in our database. So we updated the schema. And now whenever I click create, it's going to create the list. It's going to create the list item meta for each one of those, and then the YouTube meta for each one of those. And now on page load, it actually calls out to the YouTube API to get all of the videos for every single one of these channels. And now you can see they're listed on the page here. So we can see videos from Svelte Society, Joy of Code, etc. I guess I'll give you a full tour of how everything works, and then we'll take a step back to talk about like how the create list page is working. So for instance, if you click on a video, we just finished this up today. Now it embeds the video. We're on a nested route. We have all of the information about the video, like the channel name, number of likes on the video, number of views, when it was posted, and then also the description. Right now it's the entire description. We're going to add collapsing later on, or like a collapsible description. And then you can see the current video is highlighted in red. And like I said, this is literally every video for every one of these channels. So it goes all the way back like 3 years ago to when Svelte Mastery's original videos were uploaded. So of course, in the future, we're going to clean this up. It'll be paginated or infinite scroll. There also will be other ways to filter and sort the list. Right now, by default, it's sorted by when these videos were uploaded. But this is it. I can show you some examples of some of the other lists I've created. So for instance, I have the Coding Garden universe. So I have 2 channels, the archive and my main channel. And this list combines both of those together so you can see all of the videos in one place. Some fun stuff are like Silent Asia. So I like to watch videos that are in either like Korea or Singapore or Japan, a lot of countries in Asia, where people basically like walk around and maybe they're eating food or they're traveling, but they don't talk over the video. So like Dancing Bacons and Solo Travel Japan, those are some of my favorite channels for that. And then King Food is a Korean channel that will show various like restaurants and food carts and stuff, people cooking their food. But this list has all 5 of these channels in it. And so now if I'm in a mood for just watching some interesting sights and scenery and food, I can go to this list to watch them. So a lot of different lists. I guess I also created makers. So I have like, I like to make stuff, Make with Miles, Nerdforge, Get Hands Dirty, Simone Gertz. And so this list is a lot of makers that like to like build things on YouTube. So these are the lists. Let's specifically talk about how this page works, because some things are happening. So whenever you search for a channel, we're actually using SvelteKit form actions for that. Now, if we weren't doing that, you typically would kind of like separate this out into an API function, and you would have like an AJAX request on your front end that is requesting the list of things, and then they just get loaded back in. But for instance, if I search for Coding Garden, this is actually a form action. So let's show how that is working. So we have the top level form, and you can see now we're using named actions. So whenever you click this create button, that is calling the create action in the backend. But we have a nested channel search, and this also has a form which calls us a named action. So you can look on this form and you can see that we're calling an action with the name of search. So if we look in our page actions, you can see create is the one that we had last time. That's the one that's actually going to create the list, put everything in the database. And so when we click this button, it's calling this action. But when we click search, it's actually calling this action. And you can see here that it's calling the YouTube API to search for channels and then returning the results. And then we can actually use those to display in the list here. So the way the code is written is this is actually just a form submission, and we're using the enhance of the form built into SvelteKit so that we can set the loading state. But at the end of the day, we just have now form data. So in the action, you can see that we're returning an object with a property called results. So that means on the page, we get access to form.results. So if form.results exists, we can iterate over it. So that is how we're handling this. Basically, the form submits, it does the page action thing. We set loading to true, so you see a little spinner. And then when they come back, we apply the action. And here we can say, if there are any results, render them out. So you'll see that this is very different than kind of like the traditional way of making a fetch request and then just like updating some data on your component and then rendering over that. We're actually using form actions to get some nice like progressive enhancement here for the channel search. So that's how this is getting populated. And then we have the piece here where you have the channels that are being added to the list versus the one that you've searched for. So when you click add, you'll notice that it gets added up here. And this one says remove down here. So they're actually like communicating. We essentially have in the page component, we're storing the data, which is the list of channels that are going to be added here. And it communicates that down so that way this knows if it's in the list or not. So when you add it, it knows that it should say remove instead of add. So the way that we're actually sending the channels to the backend for create is just a list of channel IDs. And you can actually see that right here. So if you're newer to web development, you may not remember the days of hidden form inputs, but that's basically what we're doing here. So the channel search and then the list of channels, that's purely visual. That's for the user to know what they're adding to the list. But when we submit the form with a post request, we're actually just sending a list of channel IDs. So basically what we do, any channel that's been added to that list, we're putting in this hidden select. So there's actually a drop down here that has a bunch of channels in it. Honestly, let's actually see this in action. If I open up the source of the page and we look in here, so you can see right here, there's this select that's hidden. The user can't see it on the page, but if we look inside of it, there's actually 2 items that are holding on to those YouTube channel IDs, and that's actually used in the form submission. So when we submit the form, it's going to send these 2 values along with it, and then on the back end, we use those channel IDs to put them into the database. So that's an interesting thing you might not have seen before, where basically we can show the user something different versus what actually gets submitted in the form. So for the form submission, we did have to update some things because now we're inserting into the meta tables. All of the stuff from before is the same, but now after creating the list, we have the list ID, so we want to create the meta items. So for every channel ID that is in this list, we need to first check, have we seen this channel before? Because basically the meta table has information about all of the channels that we've seen before. So if like 2 different lists have the same channel, that's already in our database, but we're not going to add it twice. So if it's already in there, we just use it. If it's not in there, we need to go get some more information about it. So we reach out to the YouTube API to get all the details of a channel, including subscriber account, avatar URL, all that stuff. So we get all of that from the YouTube API, and then we store that in our database. Now, in the future, we would want to update this, right? Because the subscriber count changes, right? For now, we put it in our database and it just stays there, but in the future, we'll have a mechanism to update this information in our database like every 24 hours or when a user requests it or something like that. But for now, we get the data and then we put it into our database. You can see here with Prisma, we are doing like a nested insert. So we're inserting into the list item meta table, and then Prisma is able to do an insert into a secondary table with that relation. So basically, we're putting that channel info into our YouTube meta table, and then that's going to be linked to this list item meta table. So that gets created. Yeah, if it already existed, we just use that, but we actually reassign it here. That creates the list, and then we get redirected to the actual list page that just got created. So that's the mechanism for how this create page works. So I showed you some areas where we're calling the YouTube API. Let me actually show you what's going on there. So basically, every request to the YouTube API, we have encapsulated into this library called YouTube API. So instead of directly calling the API anywhere, we're always deferring to that library that we wrote that internally calls the YouTube API. So you can see it has functions like get channel by ID. It has things like search channels with a given query. We essentially wrote the code to call the API, but now the only place we call the API is in this one spot in YouTube API. So in our lib and server folder, we have a file called YouTube API, and this is where all the requests to the YouTube API happen. So you can see here, we create an instance of the YouTube API client, and we are using the official SDK for node.js that comes from Google. And this is nice to use just because they have TypeScript types. Now, not all of the types are perfect, but it's better than just directly calling the REST API because it has some types built into it. So we create that client instance, and then anywhere we need to make a request, we use that client instance. So you can see right here, we have this YouTube channel meta API response. Basically, what we've done is we have that type in our database that I talked about earlier, the YouTube meta, which has the channel name, the subscriber count, the channel description, avatar URL, all the stuff we need to know about a channel. And this is how it looks in our database. But basically what we do is we take the YouTube API response that we get and we turn it into that object, except for created at and updated at columns, because before we put it into the database, it doesn't have timestamps. So basically, this type is the type that we're going to be returning from these functions. And that's one of the other reasons that we wrapped the YouTube API, is the YouTube API can sometimes respond with like empty data or different things like that. So by reformatting it into a nice response, our front-end code that's actually using these objects doesn't have to worry about missing properties because we set all of those properties in this file. You can see we also have a type for the YouTube video. And that has all the things you would expect to have for a YouTube video. But again, whatever responses we get back from the YouTube API, we're reshaping into this, so that way it's more consistent across our code base. And then we have a couple of helper functions. So again, if you've ever worked with the YouTube API, the responses can be very finicky, right? So as you can see, sometimes dates are undefined, sometimes they're null, and they are a string. So we have a little function that makes sure that we're returning it into a timestamp. And then also things that should be numbers sometimes are null or undefined. So we parse them and set them to 0 if they didn't have a value. So a lot of these things that I wouldn't want to have to do over and over again in my front end, I'm doing here before the front end even gets the data. And then here you can see an example of taking in a channel and then converting it into that specific format that we want. And you can see that we're setting some sensible defaults here. Like if the title doesn't exist, or they don't have an avatar URL, or they don't have a description, we're setting some default values here. Now, we have a to-do because you know that this app is internationalized, it's translated, and right now we have English translations that we're just putting here. So in the future, we're going to have to handle translations for these things. But for now, this is just setting some sensible defaults that can be used in our front end. So for instance, search channels is implemented here. And so this is what we call on the server whenever we want to search for a channel while creating a list. So this is the function that gets called. You can see that we call the YouTube API. So we use the YouTube client. We get the first 50 results that match that query. And so that's 50 channels. We're specifically asking for channels. Now, after getting that, we need to get more information because the top-level search API from YouTube doesn't have all the details we want, like subscriber count and banner URL and various other statistics about the channel itself. So this is a top-level search that gives us the basic details like channel name and ID, and then we use that to call a secondary API. So there's a lot of funky code in here because basically the response that we get back from YouTube, sometimes there are literal undefines in the middle of an array that should be an array of just objects. So we have a lot of code that basically is looking at that response, making sure that the thing is there, and then reformatting it into an array of things. And then that gives us a list of channel IDs that we then get further information about. So channel parts has all the information that we're requesting. We want the snippet, the statistics, the brand settings. So statistics gives us like subscriber count. Brand settings gives us things like banner URL and their YouTube handle and stuff like that. So all of that we are then requesting after we have the list of channels that match a given query. So we grab all of that extra data, and then again, that extra data could be missing things. So we kind of like reformat it. And this extra data that we get is actually in a different order than the original search results that we got right here. So what we do is after getting back all of that information, we turn it into an array that is in the same order as the original search results that we got back here. I know, it seems like a lot. We basically we had to do this. So we reformat it. We basically, by putting all of the channel details into this map here, when we iterate over the original search results, we can now return a new array that's in the same order, but now it has the extra information associated with it. All of that to say, we now have a list of results that we can display in the UI whenever you're searching for channels. So whenever you search for Coding Garden, all of that is happening. It hits the API, gets back a list of search results, then uses all the channel IDs from that search result to get further details like subscribers and handle, and then reformats it into the format that's more consistent that we can use on the front end, and then finally displays it to the user. So that's that. So now let's talk about the individual list page. So when you go to a list, you'll see that up here at the top, we have the list title and then the list of channels that are in that list. This piece of the page is handled by our server load. So when we visit this page, we look up in the database, find the list that has this specific ID. And we do some includes here. So this is Prisma's way of including nested related data. So we get the list with that ID, but we also include all of the items. So every channel in that list, which is stored in a separate table, is now going to be joined together and will be included in that query. And then for every channel, it has meta information. And for every meta information, there is YouTube meta information. So this one query gets everything we need to know about the list. It gets the list name, the list description, and then the list of all of the YouTube channels and their channel IDs and associated information so we can display it on the page. So that YouTube meta gives us things like the handle and subscribers and title and image, so we can display all the channels in the list. Now the list of YouTube videos, that gets loaded asynchronously. So you'll see here that we grab the list of channel IDs that we got back after retrieving the list from the database. So now we know every YouTube channel that is in that list. And here we're returning the list itself that we got back from the database, but we're also returning a promise. So get videos is a function that returns a promise which will resolve to a list of videos. But because there can potentially be hundreds of videos, we don't want to wait to render the page for all of those to come back. So what we want is this stuff at the top, we'll wait for that before we render the page, right? Because if we're thinking about like SEO, if this was to get indexed, I would want the search engine to know the name of the list and the channels in the list, but not necessarily the videos in the list because that changes pretty often. So basically this piece up here is server-side rendered because SvelteKit is going to wait for this data to come back from the database before rendering the page. But because we've included this as a promise and we're not awaiting the promise, we can actually await it in our template code. So that way Svelte basically serializes this promise that can be resolved on the front end. So to see an example, let's actually create a new list. So that way it'll take a little bit longer. So let's create a list for JavaScript channels. We're going to add these 3 to the list. But what you'll notice is after I create the list, the page will load with the title and the channels, but then we're going to see a loading spinner before it actually shows us all of the videos. So let's see that. This right here. And that's because videos is a promise. So SvelteKit knew that it could render the page, but now in the front end, we have code that says wait for this promise to resolve because right now all of those videos are being cached. Now, I know right now the loading takes a long time. We talked about it before. We potentially will have like a mini game or we'll tell people, please wait, because after we load this data the first time, it's actually super fast. So if I go back to this list, it's instant, right? I don't have to wait again because we're caching the data, which I'll show you in a second. But that's the main thing I wanted to show you is that this piece of the app isn't server-side rendered, only this piece. Now let's see how we do that in the client-side code. So in SvelteKit, they have this await block. And basically what we can do is we can await a promise. And data is our page data. And you can see data has this property streamed and then videos. Now, you don't have to put this into an object called streamed. We just did that because it's basically serving up as a stream. I mean, technically I could put this at the top level and it would still work. Mainly what SvelteKit looks for is something that is a promise. And because this is a promise, streamed.videos, I can await. And so in my code here, I am waiting for the videos. And basically if the promise has not resolved, it's going to show this piece of code. So it's like a conditional promise render. So if it's not resolved, show a little spinner. But if it is resolved, iterate over all of the results to show a YouTube video embed. And so essentially, this piece of the app up here gets server-side rendered, and then this piece down here doesn't load until it's ready on the client. So now let's take a look at this get videos function so I can show you how we're doing the caching. So over here on the YouTube API, we have this function called get videos, and it receives a list of channel IDs. So for every channel ID, we call get channel videos, and then we return one big list of all the videos sorted by when they were published. Now, get channel videos is where the magic happens because this is where we're caching and also requesting every single page of videos. So you can see here it accepts a channel ID. It creates a cache key. So we are using Redis to cache this info. And essentially the cache key is just an identifier. So the next time I request videos for this same channel ID, I'm going to look in the cache with this specific key. So every channel will have a unique key. This can be whatever you want, but as long as it's unique for the things that you're storing. So if those videos are in the Redis cache, we just get it back, we parse it, and we return it. And so that's why on subsequent render, these things are so fast. So if I look at some of these other lists, they render fairly instantly because that just had to pull from the cache. Let's see, like this one. Yeah, it's a little bit of spinning, but again, it's not the really long wait because it doesn't have to call the YouTube API. At this point, they were already cached. All right, if they weren't cached, then we need to get the videos for this specific channel. So if we look at get all videos, this actually calls the YouTube API, and it calls it one page at a time. So the YouTube API only lets you get up to 50 results at a time. So basically, we're getting 50 videos at a time for this specific channel. And similar to how earlier when we were searching for YouTube channels, we also had to call a secondary endpoint to get more information. Same thing here. So search by channel ID gives us videos for that channel. And then once we have the video IDs, we can call the specific YouTube API to get all the video information like number of likes, how many views has it gotten, what is the duration, all of that extra info about a video, we have to call a separate endpoint. So we do this, and then we reformat it. So I showed you the type earlier that we're reformatting it into. Basically here, we take that data, put it into this format, and then put it into the array. And then the way the YouTube API works is paginated. So if there's a page token, then we request the next page of video. So essentially, we are requesting all the videos for a channel, and then that comes back here as a list, and we store that in the cache. And here we're telling it that it should live in the cache for 24 hours. So after 24 hours, if we check the cache again, it's going to be gone, and then we'll re-request all of that data from YouTube. Now, to show the Redis setup, it's actually fairly simple. We basically just added Redis to our Docker file. So we already have Postgres in our Docker file. We also wanted a Redis instance. So you can see here, we're pulling from the Redis version 7 image, exposing the port. So here we set up a volume just so that if the container goes down and goes back up, the cache will still exist for us. And then from there, we just connect to it. So we create a client using the official Redis library, and then we reference that client in here to either get something or set something in the cache. Now, I'm using this app called Redis Insight. It's from Redis themselves, and it shows us all the stuff in the cache. So for each one of these is a cache entry, and you can see it has the channel ID on it. So if I click on it, I can see that I think this is the one for, William Osmond 2. So this is all the videos for the William Osmond 2 channel. And then for each one of these entries is basically all the videos for a given channel. So this one is the Backyard Scientist, and then this one is Safety Third. So each one of these entries is a JSON list of all the videos for that channel, and they're stored here. So if I request videos for a given channel, it's going to pull it from this cache if it hasn't been 24 hours since the last request. Like Mr. Disa is asking, if the data changes, we won't know about it for 24 hours. And that's just how we've coded it up so far. So you can see here that we're saying expire after 24 hours. Basically, after 24 hours, when you come back, if there were any new videos published, you're going to see those, but it's going to take 24 hours. Eventually, we want to add functionality where, like on the page here, the user would have the ability to say, well, I know that this channel published new videos, so maybe I should be able to click a button that says like refresh to make sure that it has the latest data. But for now, if there are new videos, you're not going to see them for 24 hours. After that promise finally resolves and we have all the videos back, we list them out and we show them here in a YouTube video embed. So this is a custom component that we wrote that just basically shows this little card here. So it's a clickable link that'll take you to the video page, which we'll talk about next, but it has the image, it has the number of likes, it has the video duration, the title of the channel, the view count, and when it was published. So you see all of that info for each one of these cards. So yeah, the YouTube API, you have a quota for the number of requests that you can make. So every time you make a request to the YouTube API, it's hitting your quota. So by serving from the cache instead, we're not using our YouTube quota. So let's take a look at some of these util functions that like do the formatting. So we are using intil number format for this. So you can see how this says like 24K views or 56K views. Let's look at something with like a ton of views. Yeah, for instance, like this NerdForge video has 1.1 million views. So that's nice and shortened, but we're using intil number format that's just built into the web browser. So we receive the locale, and then we use that formatter to format it to the short form. And it's interesting to note because depending on the language you use, the formatting is different. So for example, in Spanish, it actually doesn't format it to be this short. It actually has a comma and will be a little bit longer than the short form that's like used in English. So this is a locale specific shortening, which is nice. We're also showing relative dates. So you can see that this was published 3 days ago, 27 days ago, 6 months ago, or 6 years ago. And that is using Luxon, which is a date formatting and manipulating library. So this is kind of like the modern alternative to Moment.js. And we can bring datetime in, and then we can turn it into a relative format. And also this is using the locale as well. And then we're also formatting duration. So this duration string that comes back from the YouTube API, I can show it in the cache here. it looks like this. So PT and then 4 minutes, 55 seconds. And it depends on the video, but it also always starts with PT and then it has hours, minutes, seconds. I think it can have days too. So days, hours, minutes, seconds. But basically we parse that using the duration object that comes from Luxon, and then we format it into the colon separated string. So on each one of these thumbnails, you can see that it's 11:23 or 7:23, etc. But basically, we're taking that duration string that the YouTube API gives us back, and we're formatting it into a colon separated string. So now let's talk about how the individual video page works. So keep an eye on the URL. Right now we're at list/list_id. And then when I click on a video, we're at list/list_id/watch/video ID. So we are actually using nested routing and nested layouts in SvelteKit to do this, because you'll see that below the video embed is this same list of channels. And basically those two pages share that data. So this list of channels doesn't have to be reloaded, because this is actually a nested route or nested layout that gets loaded at the top of that page. Let's talk about how that works. So if you look at the top level, the list ID page is actually empty. So there might be a better way to do this, but basically I wanted the top level to actually be a layout itself. So basically by having an empty page here, the list ID page uses the layout as its main layout. And you'll see that we're doing some conditional rendering. So first of all, we have this slot. This slot basically says where should the nested route be rendered, and it's at the top of the page. So this is where the video embed is going to get rendered. But then we have some conditional rendering, because you'll notice that we're not showing the list title and the list of channels when we go to a video. That actually hides. So we just have conditional rendering that says if there's a video ID param, if there's not a video ID param, then show the list title and the list of channels. But otherwise, hide it, because there's actually going to be a video there instead. So we now have this nested route called watch with video ID, and this component is what's going to get loaded into that one specific slot. And you can see in this component is where we have the breadcrumbs, which show you like the list that you can click back on, and then the name of the video itself. So essentially, whenever the route is now nested, so we're at list ID, watch, video ID, it knows that this needs to be loaded inside of that slot. And you can actually go directly there too. You'll notice that we have some loading state as well, because this information about the video, like the video title and all the video stats and everything else, we actually didn't have to make a separate request for that. All of that info is already included in the list of videos, so we're actually sharing that data. And so because it's a nested route, we can use that data which came from the parent load. And so that's why we show loading in both places, because we need to wait for the list, so that way we get back all the info, which means we can show the info about the embedded video. So let's talk about how that page is getting its data. So we showed earlier that the load for the list of videos on that page does streaming, right? So it returns a promise and it loads that list of videos on the client side. So in order for us to be able to use that data on our page, we kind of need to wait for this data to be available. So inside of the nested route here, we actually have a couple of computed properties where we're looking at that list of videos. And when that promise resolves, we're finding the video that matches this specific video ID. And then similarly, whenever that resolves, so now we know that we have the video, we are going to look at the page data we have, which is the list of channels, to find the channel that matches that specific ID. So basically, both of these are dependent on the parent route loading all of its data. And so we're basically just waiting on these so we can grab their data. The other thing you'll notice is kind of this scroll into view. So we're just using the after navigate function from app navigation. And whenever we navigate, which means we go to a new page, we say scroll into view. And basically we scroll up to the breadcrumbs and we're storing a ref to that so we can scroll it. So for instance, if I scroll down and then click on a video, it scrolls back to the top. If I click on this, it takes a second. And honestly, the video data loading is instant at this point, because we have all of the metadata about every single one of these videos in the list. So it just scrolls up and then embeds everything else. As far as the video embed, we're not doing anything special there. We basically are just using the iframe embed. So on the iframe, we specify the source to be youtube.com/embed and then the video ID, and that embeds the video right there. we set it to be full width, and aspect video comes from Tailwind, which just sets an aspect ratio of 16:9 because it's a YouTube video, and that embeds it. In the future, we'll use the YouTube JavaScript SDK, so that way we can control autoplay, and then also like videos that have timestamps. We can parse those timestamps in the description and have a very similar functionality to YouTube. Like when somebody clicks a timestamp, automatically seek to that place in the video. With just the plain old iframe, you can't do that directly. You basically need some custom JavaScript that can get access to that and send commands to do things like pause the video, play the video, seek to a timestamp, that kind of thing. So the last thing I'll talk about is how do I get the currently active video to turn red. So you'll notice when I click on a video, if I scroll back down to the list, we can see this is the one that's highlighted. Essentially, I'm passing a prop down to the YouTube video embed component, and I'm saying active if this video ID is equal to the current video ID that we're looking at. And video ID comes from the URL here. And so if active is true, inside of that component, we conditionally render a class. So you may not have seen this in Svelte before, but basically what we can do is we can say add this class to this element if this expression on the right-hand side evaluates to true. So if active is true, we set variant filled primary to be a class that's applied to the element. So that's all I have for you. The app has come a long way, but we still have a lot more work to do. Let me just talk about some of the things. First of all, you're probably already yelling at the screen if you know anything about anything. You're like, that's so much data to cache. Why do you have thousands of videos all on the same page? I know. We need to add pagination. We need to add infinite scroll. We're also eventually going to start working on the features of the page itself. So right now, the videos are sorted by publish date, but it would be nice to sort by most popular videos or videos with the most likes, or sort by duration. Also, we want to be able to keep track of videos that you've watched. So say, for instance, you're in a list and you decide you want to start watching this video. When this video is over, we could go on to the next one in the list. Depending on the list that we're showing, whether it's by when the video was published or sorted by popularity, that kind of thing. So there's a lot of functionality we need to add there, and also some logic that needs to be worked out in terms of like how we're caching things and how we're pulling all of that stuff in. All right, thank you so much for watching this. Quick advertisement for my course React Roots. So on April 10th, React Roots starts, and it's going to be across 8 live streams that will be streamed for free on Twitch. If you go to reactroots.com, you can learn more about all the lessons that are going to happen and the details of everything. And like I said, you can watch for free on Twitch, but if you'd like to pay for a ticket, you essentially get to be a part of a live classroom. You'll be able to ask questions, I'll give you feedback on your exercises, and you will get access to the exercises and projects. So if you're interested in this, check out reactroots.com, and I definitely hope to see you in the live streams when I do that. Also, if you found this useful or any of my other content useful, definitely consider supporting me. I have GitHub sponsorships, so you can support me for $5 or more a month. You can also make a one-time donation, support me on Patreon, become a YouTube member, a Twitch sub, or we have various merch. And actually, there is a sale happening right here, right now. So if you go to merch.coding.garden, you use the code FRIENDSANDFANS25, you can get 25% off anything in the store. And I still get about $5 profit from anything that you buy. So like this shirt, the Dark JS, you can get this in the store. You can get my code mug, etc. I think that's it. Thank you for watching this. We are going to take a break from Listed for the next 2 weeks because of the React Roots course, but we'll be back for Listed the 2 weeks after that. So thanks for watching this, and hope to see you in the Twitch chat.